Okay, thank you. So good afternoon, everybody. So yes, indeed, my name is Lefebvre. I'm from the Belgian National Ref Lab for FMD. The work which I will present is mainly performed by my colleague Frank van den Busse. So I will talk you about how tailed primers enhance the real-time RT-PCR detection of FMD virus. So in our lab, and as in many other reference laboratories, we have two different real-time RT-PCRs. We have the 5-UTR-based technique from Reed et al., the 3D-based technique from Callahan et al., and particularly for diagnostic samples, we use both techniques at the same time, as it has been demonstrated previously that in this way you have an optimal diagnostic sensitivity. Now, what about specificity? So I'm from a country that is free from FMD without vaccination since quite a long time. So from time to time it happens that our authorities give us a sample and they say to us, well, can you please show that this sample does not contain any FMD virus so that we can exclude the possibility that there is FMD. Then we say okay, and we do the test, and then we get a result like this. So what you see here is that this is our positive control RNA, which was included in the test. And then we get a result for the sample like this, which is more or less around the cutoff value for positive or a bit below that value. And then, of course, yeah, we are not so happy with it because we do see something. So what is going on? It might be that we have contaminated our sample in the lab, but for that we actually have very stringent cleaning and decontamination protocols to exclude this possibility. It might be that there is something in the sample that cross-reacts with the primers and the probes, although if you look at literature results, the chance that it happens is very low. It might be that there is nothing in your sample, but actually that the reagents that you are using to do the PCR on themselves create a positive reaction like this. Or maybe, yes, it still is possible that your sample does contain a small amount of FMD virus. Ah, sorry, I'm standing too far. Okay, so therefore we wondered how can we improve the robustness and overall performance of our assays. Now then, when you would look into literature, one of the techniques that has been described is actually the use of primers that have so-called flaps on their 5' end of their primers. So what is this? These are actually AT-rich overhangs that are non-complementary to your viral template. And as it has been shown in this graph from the United States already for some time ago, that if you attach the right sequence and the right length of this flap to your primer, that for an example, in this case, you can get a 60% improvement of the fluorescent signal in your PCR. And for an example, our colleagues from the Friedrich-Lefebvre Institute in Germany, they have used this technique to optimize their real-time RT-PCR protocol for the detection of classical swine fever. So my colleague Frank van den Busse, he started working on this, and so he designed an optimal flap to hang on the 5-UTR and 3D primers. And so I will first show you the results of the 5-UTR. So what you see in this graph is that we have actually a dilution series of virus that have been performed with the non-tailed primers indicated in red, and then the tailed primers indicated in blue. And what you actually see is that when you use tailed primers is that you have a faster accumulation of your fluorescent signal and also to higher levels. It's important to say that this effect is bigger the lower the amount of viral RNA in your sample is. And we've also noticed that the effect is bigger for the SAT strains than for the Eurasian strains. When we look then more into detail and start playing around, for an example, with a tailed forward primer and a non-tailed reverse primer and vice versa, then we actually observed that the majority of the effect is associated with the tailing of the forward primer and not of the reverse primer. And then when looking even more into detail, we actually observed that when you are using non-tailed primers, at a certain moment you get an accumulation of double-stranded artifacts that are associated with your forward primer and that have a positive, that have an inhibitory effect on your PCR. And when you use a tailed forward primer, you actually have a very significant delay in the formation of these forward primer-derived artifacts. Then for the 3D, the picture was completely different. So we've tested 50 reference FMDV strains from the 7 different serotypes. For 45 of those samples, we didn't observe a clear effect. But for 5 of those samples, we had a clear positive shift in the CQ value. Now, what is shown here, this is the first one is a reference strain. And then the 5 other ones are the 5 strains in which we observed the positive effect. And what you see, this box is actually the place where your forward primer attaches. This is then the place where your reverse primer attaches. Then from this side to that side, actually you have your probe. And in the red box, what you see is that you have actually a place that contains a palindromic sequence just next to the attachment site of your primer and very close to your probe. And what actually happens is that in the 5 isolates, you have a certain mutation that actually, several mutations that actually extend the palindromic sequence. So if you would look, this is actually what happens. So this is the normal situation on the left. So you have your RNA template with this palindromic sequence that forms a stem loop structure. You then have your forward primer that attaches your probe. And because of the mutations in some of those strains, you actually see that you have an extension of the hairpin structure. This hairpin structure, because of that, it becomes a very thermostable structure. It's very close to where your forward primer attaches. And because of that, we assume that there is an interference with the annealing of your forward primer. And so for the moment that you then attach the flap to your forward primer, you can actually get around the fact that your forward primer has difficulties to attach when this hairpin structure is present. Now, what I have told you right now is actually just the top of the iceberg, so there are many more effects which are playing when you are using the flaps on the forward and reverse primers, but I have shown you the most important ones for the 5-UTR and the 3D. So everything is now available since recently in an open access paper in which you can find all the details and all the explanation. Most importantly, in this paper, you will also find the sequences of the forward and reverse primers. And of course, I invite all of you to test it out for yourself and see what positive benefits it might have for your own diagnostic real-time RT-PCRs for FMD. And then last but not least, I thank you for your attention.
Thank you very much, and thank you for staying well in time. So, are there any questions? Or was it a bit too technical? Okay, done.
So can I ask an obvious question, which is, does adding the tails impact upon the analytical sensitivity of the dynamic range of the test?
The analytical sensitivity. Yes, but it's a long time ago that I performed the test for the analytical sensitivity. So, but I cannot give you the right numbers right now. But it has the test. In fact, it has a positive effect both on the sensitivity and on the specificity, and particularly also if you would look at at very low concentrations and things, you do have a positive effect, yes. Yeah. The range, I don't know the numbers anymore by heart, because it's already, the technique is already validated in our lab since 1 or 2 years. It's under accreditation. But the tests which were performed for the accreditation file, it's already quite some time ago, so I don't know the numbers anymore. I'm sorry.
But we can look into it and come back to you.
Yeah.
Any other? Yeah, John?
So just to clarify what you said at the end, that was quite interesting. You've now replaced the old primer sets.
Yeah.
This is not just a research chat. This is an assay that you're using as a frontline guide.
Yes. Yeah. Also something that maybe I can say. So in our accredited tests, we have tailed forward and reverse primers, because we already started the validation process before we did the extra experiments which are described in this paper. If you would just look in the paper, it seems that it would be enough if you would just put tails on the forward primer, but we are using the tailed forward and reverse primers. Yes. Yeah.
And we also wanted to understand the mechanism before we communicated anything.
Yeah. Yeah.
Any more questions? If not, then we move on to the next one.
Okay. Thanks, David, and great presentation.